Alright, so this is going to be my video for section 3.1. I think it's in the book, it's just called association correlation, but I'm going to sort of concentrate, especially in the start, with these scatter plots. Now, on these videos, I used to make them all the time, and then all the videos that I've previously made have been deleted. So I'm going through and I'm remaking these. Now, this video is to supplement what we really are doing in class. Those of you who I lose along the way or you're absent, go back and watch these videos, and we're not going to get to the specific examples like the cricket problem or the who stole my Mountain Dew question, but this will just paint a picture of what's going on. So, pause as I'm going, take notes, add to the notes that you'll need for your note quizzes. So this is just in addition. Alright, so let's get into chapter 3. Alright, so chapter 3 is all about looking at the relationships between two quantitative, now remember, quantitative variables from chapter 1, variables that would make sense to find or use arithmetic operations on to find an average. Your book will, I think, uses the term bivariant, bi just meaning two. So we have two quantitative variables, an explanatory and a response. Now let's start there. In class, we've talked about, we looked at the amount of rain versus the weed growth in your yard. The rain is explaining why weeds are taking over my yard, or maybe there's a lack of weeds in my yard. So your explanatory variable will always be on your x-axis, and the response, or the response variable, will be your y-axis. So the explanatory variable, your x variable, is explaining what we're seeing in the response variable. And maybe for this problem, we might say our explanatory variable might be your height, and the response variable might be your weight. All right, as height increases, weight tends to increase. Most people that are 6'5" probably weigh over 200 pounds, and most people that are under 5'5" probably weigh under 170 or 180 pounds. Now there are exceptions, but this is an overall trend. All right, now keep in mind, for these problems, we're not going to look at categorical variables, so you're not going to see my favorite color or your favorite color on either one of these axes. Probably the most important thing, and I hit this in class, but let me take note of this: stay away from the words cause and effect. So stay away from cause and effect. And let me apologize, my handwriting on this is not real good. Alright, the only time we're going to use cause and effect is once we get into chapter 4 and start talking about designing a valid experiment. And it's a lot of work to show cause and effect. All we're looking for now is there an association between two variables, and ultimately is there correlation, which I want to get to in just a second. Alright, so no cause and effect. I do not want you using those words in this chapter. Okay, so X is your explanatory, Y is your response. Now this leads us to 4 questions that we have to ask every time we're doing one of these problems. Alright, those questions are the direction, strength, form, and any potential outliers that we see. Now the direction, it's pretty easy. Alright, that's going to simply be positive or negative. If you go back to the previous problem, as X was increasing, you saw Y increasing. All right, there's the direction there is positive. All right, as X increases, Y can also decrease. All right, that would be negative. So we need to make note of the direction. Don't put a plus or minus. Actually, write that out. But that's the first question you're going to ask. All right, the strength. Now the strength, I'm going to put a little star here because that's probably one of the main topics in the chapter, or at least calculation-wise, the main topics in the chapter. The strength is going to be, we're going to use a number called number. I'm going to use R to denote this, and that's called the correlation coefficient, and I'll get to that in a second. All right, so the strength is going to be simply how spread out are our points around this line that we're trying to look for. Are the points pretty tightly centered around the line, that's a higher strength. Or are the points spread out so much that we really look at it and we say that this association or the correlation is pretty weak. All right, so our strength is going to be our correlation coefficient. And also keep this in mind, our correlation will measure, that value R will measure the strength. And we'll get to some problems here in a second that really get into that. All right, the form is going to be basically, what do we see? What's the overall pattern? And for our purposes, we're really going to concentrate on the linear. All right, so we're going to make least squares regression lines. All right, so we're really looking for a linear pattern. Doesn't mean you're always going to see linear. We talked about the problem about baking a turkey. You can get to a certain point where the turkey is overbaked and it becomes burnt, or it's tough to eat. So you see that parabolic sort of shape there. But we really want to see a nice linear pattern so that we can do the calculations. And also keep in mind, you're never going to see a perfectly straight scatter plot. All right, there's going to be deviations off of that. A perfectly straight scatter plot or data that shows a perfectly straight line, that never occurs in the real world. All right, so no data set's going to give you a nice straight line. That's a true data set. And the last one, outliers, and I put a question mark here. You're just going to simply make note of any departures from the bulk of the data. All right, so if you see a data point that just sort of stands out to you, you're going to make note of that. You're just going to write down in your description of what you're seeing, this point sort of stands out, or maybe these 3 or 4 points stand out. And start asking maybe why you're seeing those points. You may not be able to answer that question, but if you feel like you understand, or you know why there's some big discrepancy, maybe try to start thinking of an explanation on that value. So if I give you a scatter plot, I'm just going to make this up. Okay, so I'll look at this scatter plot, maybe put a couple more points up here. All right, so let's hit all 4 really quick. All right, the direction of this, if I was to throw in a line of best fit, now obviously we're going to let the calculator come up with this line of best fit, this fit for us, but let's say that this is our least squares regression line. Our direction here is negative. All right, so as x is increasing, y is decreasing. So we'll take note that we have a negative direction. The strength, if I'm looking at this, all right, this looks, there's an obvious pattern. I'm not going to say that this is, I mean, it's obviously not a perfectly straight line, but I would say our strength here is fairly strong. This may have a correlation of, let's say, I don't know, negative 0.78. Okay, so it's fairly strong correlation. The negative, by the way, whenever I write this number down, the negative is just sort of dictating that direction once again. The form, a line seems to represent this data pretty well, so I'm going to say this is linear, so that's why a least squares line is appropriate. In outliers, if I'm looking at this, I don't see really any points that sort of stand out to me that don't really fit the rest of the data. An outlier here might be a point like maybe this point. I'll put a little X here. Maybe there's a point right here that sort of just stands out, doesn't really fit the data, and we would take note of that if there was a point there. All right, so that's the idea of what you're going to do. And also keep in mind, I'm doing this out loud. I'm not writing everything out because I can't, because I'm using a stylus. But on your homework, classwork, on a test quiz, you would need to probably write full sentences for those 4 questions. All right, now to finish this up, let's talk about this idea of the correlation coefficient. See. All right, so correlation coefficient, we're going to use R to represent that, and it's going to be a number between -1 and positive 1. So any number in between will be fair game, all right? And obviously 0 is right in the middle. If you have correlation of 0, that means there is no pattern. It's just a it's a scatter plot that sort of looks like this. All right, it's just random points and there's no obvious pattern. All right, there's no correlation whatsoever. Correlation of positive 1 is just a perfectly straight line, all right, increasing. Correlation of negative 1 is the exact opposite. Ooh, that's not very straight at all. But just imagine a straight line that is decreasing. All right, well, and I've said this before, you will never see 1 and negative 1 in the real world. You're going to see values that fall somewhere in here or somewhere in here. All right, and also correlation is just a number. There are no units on correlation. All right, it's just a number that measures strength, and it sort of leads to the idea, we talked about this in class, all right, there need to be cutoffs. I think for our purposes, I'm going to tell you that if R is greater than 0.7 or negative 0.7, remember the negative doesn't really mean much for the strength. If R is greater than 0.7, we're going to start calling that strong. All right, if it gets higher, 0.8, 0.9, 0.9 is very, very strong. You're getting really close to that positive 1. If R is less than 0.5, we're going to say, or around 0.5, we're going to say that that's weak. And as we get closer and closer to 0, then we get to no correlation. So as R gets closer to 1, the strength goes up. As it gets closer to 0, the strength goes down. If I give you another scatter plot, and let's just make this one negative. All right, so if I'm looking at this looks linear. I think it is decreasing from left to right, so it's got a negative direction. All right, the strength of this, there's pretty big gaps between our data points and the line, so I'm going to say that this has a correlation of about, let's say, negative 0.5. So it's fairly weak. Okay, so get used to this. We're going to find this number. We're going to rely on the calculator to give us our correlation coefficient. All right, but it's probably pretty important that you can look at a data set and at least give some approximation to what the R value should be. All right, now the last question. Let's look at one more example of a scatter plot and answer those 4 questions, and I think you'll have a pretty good understanding of what's going on in this chapter. So if I make this scatter plot, let's put your height versus your weight. So my height is going to be my explanatory variable, x for the x-axis, weight's going to be our response. And then let's say our scatter plot looks something like this. Okay. All right. So obviously the direction here is positive. Okay. So we have positive direction. Oh, writing's getting sloppier. All right. I see a linear pattern for the form. All right, the strength, if I'm looking at this, I feel like there's pretty good correlation between your height and your weight. All right, so I'm going to say that this is strong, and I might even go as far to give an approximation to the R value and say that maybe we have an R value here of maybe 0.8. I'll make this maybe 0.83. So R value of a positive 0.83. And for our outliers, there doesn't appear to be any outliers. So no apparent outliers in this problem. So you're going to answer those 4 questions every time you're working with a scatter plot, and in particular that idea of a least squares regression line. And then in the next video or in my notes, I will get into more detail on how to calculate this least squares regression line.